You're driving to your sister's house when all of a sudden the sky changes. The cool weather becomes scorching hot in a matter of minutes. People who were going for casual autumn strolls have now taken off their jackets and are sweating. People who were planning on going for a weekend ski trip have canceled their plans at the last minute to head to the beach. It was sunset, but the sky has become as bright as day. You fish out your sunglasses and continue driving. Nothing seems normal, but people don't seem to care. You put on the radio and hear everyone panicking about the sun. Nothing is cohesive. They're jumbling up their words and saying a gazillion things at the same time. You take out your phone and see what's happening on social media, and it's all the same thing. Nothing is comprehensible. It's just people talking about how the sun is getting closer to the earth. Footsteps are clacking along a quiet hallway. A man dressed in a sharp suit is making his way to one of the most important meetings of his life. Adam walks through the meeting room while everyone is waiting to hear what he has to say. As the head astrophysicist, it's Adam's responsibility to figure out what is happening and not let the public know what's going on. Otherwise, the whole world will succumb to panic and mass hysteria, which won't be good. He takes a seat at the head of the table while everyone waits for what he has to say. The room is tense and no one is saying a word. He takes off his glasses and places them on the table. Everyone is watching his every move. He takes a few files out of his folder and starts reading. His voice can command a room. My fellow colleagues, I'm afraid the worst has fallen on us. After countless hours of consistent observation and analysis, we have discovered that a piece of the sun has abandoned its orbit and it's making its way toward us. We still don't know which part of the sun, but we know that once it strikes us, we may not have an Earth to call home any longer. The tension in the room is palpable. Everyone looks at each other confused. Adam answers as many questions as he can, but he himself doesn't even have some of the answers. In a matter of minutes, the press leaks some voice recording of Adam's speech, and the world goes berserk. Back to you. You just heard a snippet from Adam's speech and aren't too convinced of its validity. Even though the sky is getting brighter by the second, there's still no reason to panic. You continue driving, and suddenly you sense an intense vibration. Your car lifts off the ground and the windows shatter. You get out and duck for cover. You saw a comet-like object strike down in the middle of nowhere, miles away. More of these objects look like they're heading toward the ground. You start your car and drive off, trying to find a place to hide. Ashes start covering the sky, which makes it even hotter than it already is. The earth is scorching. Meanwhile, traffic is piling up for people who want to escape but don't have any real place to hide. You eventually abandon your car and go on foot, trying to find a place to cool down and get away from the sun's rays. Even though ash is covering the sky, the sun is still blasting through it. You head to the woods and find a cave to cool down in. It's still hot, but at least you can calm down and figure out your next move from there. You get out your phone and try to see if there's any news updates on what's happening, but nothing seems to be updating. You keep refreshing it, but nothing works. Suddenly, you hear some people getting closer, and they order you to step outside of the cave. Adam is with the top scientists in the world, trying to figure out a solution. Everyone is presenting him with solutions, but in the end, none of them are achievable. They've spent hours in the office, but with each passing minute, the sun is getting stronger and the sky is getting brighter. It feels like nothing can be done until Adam has an aha moment. He calls for everyone's attention and asks for the extra people who are not contributing to leave the room. He mentions that they need to launch a rocket into space that can divert the large mass heading toward the Earth before it breaches the atmosphere. They only have a few hours before the sky becomes completely dangerous and unsuitable for flying. As for now, all flights around the world have been canceled. There is only a small window of opportunity to get this rocket out there and save the world. Adam summons the best engineers he can find to adjust the rocket and the astronauts who will volunteer for the mission. They go into quick basic training and start planning for the next steps. After many briefings, they're ready, but they only have one shot at diverting the large object. The astronauts are ready and begin to enter the rocket. Suddenly, you pop up out of nowhere, dressed in a spacesuit. You're one of the prominent astronauts for the mission. Those people who found you in the cave were from NASA, trying to recruit you for the mission. You meet with Adam, and he quickly briefs you about your role. Because the mission is very last minute, there wasn't even time for Adam to sit with you and give you the proper training or brief. You enter the rocket and take your seat. The engineers and scientists gather around to make sure that everything is in order before takeoff. The large object is getting closer, and if the rocket is delayed, then it'll melt when it reaches the final part of the mission. You're strapped in, and the rocket starts rattling. All systems are in order. 3, 2, 1, blast off. The rocket picks up and shoots into the sky. There are extra layers of visor shield protection, since it feels like you're getting closer to the sun. After a few minutes, the rocket leaves the Earth's atmosphere and is at the forefront of the large object. The rocket suspends itself in a certain strategic position, waiting for the right time to swat the object out of the Earth's trajectory. Meanwhile, everyone back on Earth is hiding in bunkers when the loose debris strikes. A cleanup team will be ready to get rid of the space rocks that will be scorching hot. The bunkers are equipped with food, water, and electricity in case they have to remain underground for a while. Only a few minutes left until the moment comes. You press a button and get ready to deploy a large spike that's as long as the Statue of Liberty. The spike is kept on a stand that's attached to the rocket. It will fire the spike like a bow and arrow and shoot it straight through the large object, breaking it before it melts. There's less than 1 minute before impact. The arrow is stretched and released. The tip of the arrow has a titanium drill that will continue drilling through the object as soon as it hits. The arrow is released and shoots through space, breaking little pieces of space objects along the way. As it speeds through, it finally hits the large object and drills through it. But nothing seems to be happening. The drill is barely getting through the center. Luckily, Adam had already thought of a backup plan. The rocket, still suspended in its spot, fires a laser where the spike is to speed things up. The laser starts melting through to get to the core. The object is getting closer and is speeding up. The object still hasn't broken into pieces yet. Less than 2 minutes until impact, and everyone is running out of options. Adam has one last trick up his sleeve. He orders everyone to evacuate the rocket and move to the backup pods. He wants to put the rocket on a straight collision course with the large object. There's too much confusion. Everyone, including you, quickly heads to the pods and ejects to a safe distance. These pods won't float around in space since they have pressurized air that allows the pods to move in whatever direction the driver wants. Everyone shoots out of the rocket while it goes full speed at the object. They're both going, heading for each other at full speed. There are only a few seconds until impact. The whole world is watching. This rocket is now the only hope there is to save everyone on Earth. The rocket starts melting before impact, and suddenly, a large shockwave ripples through the sky. The rocket was able to break the large object into many pieces. The problem now is the smaller debris falling onto Earth. But since everyone is in bunkers, they're safe. Adam and his colleagues celebrate. You and the rest of the astronauts are safe and make it safely back to Earth. The next phase for everyone on Earth is to rebuild everything that was destroyed. People will have to start everything from scratch, but this is only the beginning of a new chapter in life.
What happens when a star runs out of its fuel? First of all, paradoxically, it grows to 1,000,000 times its original size. You see, when the core of a star runs out of hydrogen, it starts contracting under the weight of its own gravity. But some hydrogen fusion continues in the upper layers. While the core contracts, it heats up. This causes the upper layers of the star to heat up too and expand. The radius of the star increases. As the star grows, it engulfs any matter, even its own planets, in its wake. Astronomers have watched stars right before or straight after swallowing entire planets, but until recently, they have never seen the process itself. Scientists from different universities have reported that for the first time in history, they've observed a star swallowing a planet. And this tragic event happened not somewhere in a faraway galaxy, but in our own Milky Way. some 12,000 light-years away from us. Astronomers spotted an outburst from a star, which is around 0.8 to 1.5 times the mass of our Sun, near the eagle-like constellation Aquila. It became over 100 times brighter than usual in a mere 10 days, and after that, it quickly faded away. Even more interesting, this white-hot flash was followed by a longer-lasting signal that was also colder than the first flash. And this combination, my friend, could only mean one thing. The star engulfed a nearby planet. What planet was it? Astronomers believe it could be a boiling hot world from 1 to 10 times the mass of Jupiter. Such planets are also called hot Jupiters. They're giant exoplanets similar to the Jupiter we have in our solar system that need less than 10 days to orbit their stars. The planet we're talking about had been gradually spiraling toward the star until it was pulled into its atmosphere and, eventually, into the core of the perishing star. This galactic feast happened between 10,000 and 15,000 years ago when the star was about 10 billion years old. And given its respectable age, the swallow itself happened lightning fast, in one fell swoop. This is very different from other hot Jupiters, which were quite delicately nibbled by their stars. Astronomers aren't sure if there are any other planets orbiting this star, perhaps at a safer distance, but even if there are, thousands of years will probably pass before they become the star's main course or dessert. In any case, now that astronomers know what they should search for, they're going to be on the lookout for more cosmic gulps. Because one day, our planet, as well as part of our solar system, will suffer the same fate. Everything around us will be gone in a flash. But you may relax and breathe out. It won't happen for another 5 billion years. That's when the sun is supposed to burn out and expand so much that it will swallow the inner planets of the solar system, Mercury, Venus, Earth, and Mars. If people manage to colonize some other world by that time, which should be at least 10,000 light years away from Earth, they would be able to observe this catastrophe. The sun would suddenly become much, much brighter, and it would eject some material into space. It would swallow several planets, including Earth, before nonchalantly setting back to what it was. But stars are not the only things in the universe that swallow other space objects. There's another kind of cosmic monsters that munch on everything, even light. Have you guessed? Right. I'm talking about ruthless black holes. But what is more interesting, they not only devour stuff, but also seem to spit it out. Not so long ago, scientists found out that the supermassive black hole at the center of our home Milky Way galaxy seems to be leaking. Why is it a game changer? Because it might mean that this black hole, called Sagittarius A*, whose mass is 4.1 million times the mass of our Sun, isn't a sleeping giant as previously thought. It might still be active, and this leakage may be the whole hiccuping while swallowing clouds of gas. During the research, the team of astronomers used the Hubble Space Telescope. It helped them spot a jet that looked like a blowtorch. It was pushing into clouds of hydrogen at the center of our galaxy. The jet seemed to spew gas like a hose directed into a pile of sand. This often happens around active black holes, surrounded by the material, pulled toward them by their immense gravitational pull. Some of this material gets into the black hole, but a small part of it gets swept outward by powerful magnetic fields. The research suggests that when a giant gas cloud gets too close to our supermassive black hole, it gets swallowed, and then the hole belches mini jets of matter. Fermi bubbles might be the result of the belches that happened around 2 to 4 million years ago. But recently, scientists have discovered another giant glowing bubble of hot gas. It aligned with the jet stretching for 35 light-years or more from the supermassive black hole. Astronomers suspect that the jet could have plowed into this bubble of gas and inflated it. Now I'll tell you something even creepier. There seem to be black holes that might be eating each other. Well, kind of. They're actually trying to share their meal at the moment, but who knows what will happen in the near future. But let me go into detail. Astronomers have spotted 2 supermassive black holes, feasting on the cosmic material of 2 merging galaxies in distant space. These giants have been located with the help of the Atacama Large Millimeter Submillimeter Array of Telescopes, also known as ALMA. These telescopes are in northern Chile's Atacama Desert. Scientists originally used them to watch 2 merging galaxies located about 500 million light-years away from Earth. Astronomers have also noticed that two gigantic black holes were growing alongside each other not far from the center of the coalescing galaxy, UGC 4211. Apparently, these black holes came across each other when their host galaxies collided. One of the black holes is around 200 million times the mass of our Sun, and the other is a bit smaller, about 125 million times the mass of our star. Even though they aren't visible directly, the black holes are surrounded by bright clusters of warm, glowing gas and stars. All of this has been tugged close by the black hole's gravitational pull. Times will pass, and these black holes will start circling each other, and eventually they will collide, creating one, probably even bigger black hole. Scientists have been observing these black holes across multiple wavelengths of light and have come to the conclusion that they are kinda unique. They're located the closest to each other astronomers have ever seen. The distance between them is a mere 750 light-years, which astronomically speaking, is just next door. Even more exciting, this distance is close to the limit of what modern technologies can detect. Interestingly, such ginormous merges are more typical for distant galaxies. This makes it harder for Earth-based telescopes to see them. But the sensitivity of ALMA helped astronomers observe those bright and compact regions where matter swirls around black holes. Imagine how surprised astronomers were when instead of one black hole, they saw two of them, munching on the dust and gas stirred up by the massive space merger. The most important thing about this discovery is that it may mean that such black hole binaries are likely to be much more common than we previously thought. And if pairs of black holes are so common, it might make it easier for us to study gravitational waves that occur when black holes collide. Such waves are also known as ripples in spacetime. If we talk about the recently discovered pair of black holes, it might still take them several hundred million years to crash into each other. But by observing their behavior, scientists can figure out how many binary black holes that are about to collide exist in the universe.
What if the sun went boom? Well, you can guess it would be super bad news for us. This was sure a short video, huh? Nah, wait, I have more. If the sun blew up, chaos would ensue in our solar system. But scientists tell us that it will certainly happen one day. But why? How exactly would events unfold? And is it possible for us to somehow survive this event? Hey, let's delve into it. First of all, get ready for a journey to the sun's core. The sun's heart is packed with hydrogen atoms, having an out-of-this-world dance party. These atoms are so excited that they smash into each other with all their might. And when they collide, something magical happens. It's called nuclear fusion. And in this fusion fiesta, the hydrogen atoms combine to form helium atoms, a chemistry experiment on a grand scale. During this nuclear fusion, a teeny bit of mass from the hydrogen atoms is transformed into a massive amount of energy. It's Einstein's famous equation E equals mc squared coming into play. Energy is unleashed in the form of light and heat, radiating outwards to brighten up the entire solar system. And once all these processes get going, a bunch of energized particles called photons join the fun. These photons are like tiny packets of light, bouncing and zipping around in all directions. They play a crucial role in carrying the sun's energy through space, illuminating our world and warming our cozy planet. But to keep all this going, so that atoms don't escape and create complete chaos, the sun's core needs to be under tremendous pressure. This pressure comes from the immense weight of the sun's outer layers pressing down on the core. The outer layers are squeezing the inner core. But the inner layers don't give up. The energy created from fusion and the bustling photon party tries really hard to escape the sun's core. But the core is so dense, like me, and the pressure is so big that the energy takes its sweet time to make its way out. It bounces around, gets absorbed, and re-emitted by other particles. Eventually, after a long time, it reaches the sun's surface and zooms off into space, reaching us as sunlight. So now you know how the sun works. Now, what happens once it reaches the end of its life? Well, here's the twist. Our sun has a limited supply of hydrogen fuel. In about 5 billion years, it'll run out of its fuel. After that, the star will undergo some big changes. Now, pay attention, because there's a pretty good chance we're all going to miss this. First, the sun will puff up and become a red giant, exploding like a balloon. It will grow so big that it will swallow up the inner planets, including our beloved Earth. Talk about a sun taking up all the space. So we won't even see the end of our sun unless we move somewhere further away. After the red giant phase, the sun will shrink a bit. Its outer layers will fade away into space, leaving behind a beautiful planetary nebula. It'll be revealing its glowing core. Ooh! The core, now filled with helium,
will start sounding weird.
and we'll start fusing heavier elements like oxygen and carbon. These reactions won't be as energetic, like a party with less dancing and more chill vibes. Eventually, even the helium will be used up, and the sun will become a compact white dwarf, a stellar retiree enjoying its retirement home. Scientists estimate that the sun has about 7 to 8 billion years left before it dims its lights. Don't worry though, by that time, humanity might have traveled to far-off galaxies, or maybe even evolved into amazing space beings. So our sun won't go out with a bang like fireworks. It's not big enough to become a supernova or a black hole. Those stellar superstars need way more mass than our sun to pull off those cosmic tricks. But what if it blew up very suddenly, just like an abrupt event without any reason? Well, let's see. Imagine this: the sun goes boom and Earth is in for a wild ride. The event unleashes an insane amount of energy, sending a shockwave racing through space at the speed of light. It takes about 8 minutes for this shockwave to reach Earth. Why? Well, the sun is a whopping 93 million miles away from us on average. So it takes a little over 8 minutes and 20 seconds for the sun's light to travel all that distance and reach us. But let's talk about the event itself. It would be a great sight to witness, but sadly, it would also be the end. Roll credits. The crazy amounts of unleashed energy would cause the sun to expand rapidly, again swallowing up the inner planets, including our Earth. And that's not all. Brace yourself for a massive burst of radiation. The sun would unleash a torrent of supercharged particles. We're talking about X-rays and gamma rays, the kind that can seriously mess things up. When these high-energy particles hit the atmosphere, they go wild, causing all sorts of chaos. They ionize the atmosphere, creating a ginormous electromagnetic pulse. This pulse is like a shockwave for electronic devices. It fries them, zaps them, and leaves them useless. So if your gadgets aren't protected, they're in for a rough time. Speaking of rough times, after that, it's instant vaporization for our planet. But the sun's grand finale just doesn't mess with Earth. It wreaks havoc on the entire solar system. That massive burst of energy would be crashing into everything in its path. Planets and other objects get knocked off of their cozy orbits, causing chaos and unpredictability. The asteroid belt between Mars and Jupiter, kapow! It's gone, obliterated, or scattered to the cosmic winds. And even planets that will survive this event will probably go off their orbits to wander somewhere. And let's not forget about the outer planets, like Jupiter and Saturn. These giants generate their own internal heat, which keeps them cozy and attracts lots of moons. But the sun's boom would steal their warmth, turning them into incredibly cold places. And now that we've discussed how catastrophic all this would be for everything in our solar system, let's ask the logical question: can humanity make it? The short answer is nope, we wouldn't make it. Everything would be wiped out, except maybe some sneaky bacteria hiding in the shadows. But in a crazy scenario where the sun gave us a heads up about its plans, we might have a fighting chance. If we knew in advance and had time to prepare, we could get our survival gears turning. So what could we do? Since Earth itself won't survive the sun's tantrum, we'd have to move somewhere. Remember how we mentioned that not all planets would be completely destroyed? Well, sadly, the ones closest to the sun, Mercury, Venus, and Earth, would disappear. So the easiest option would be to move to some other solar system with its own Earth-like planet. But what if the Earth somehow managed to survive this catastrophe? Let's not think about how it happened and just discuss the consequences. Well, our climate would go crazy. During the first moments of the sun's kaboom, the radiation and particles would crank up the temperature big time, like a never-ending heat wave. We're talking major greenhouse effect. The oceans would evaporate, creating thick, fluffy clouds that trap heat and refuse to let it escape into space. And after that, without the sun's warm embrace, the Earth would quickly become an icy freezer. So we'd have to think outside the box. One idea would be to take shelter deep underground, where we won't be that much affected by radiation and sudden temperature changes. As you dig deeper, the temperature rises. So, with the right tools and resources, humanity could hunker down in fortified bunkers, surviving for a couple of years without the sun's rays. Why just a couple of years? Well, remember how we said the sun is a gravity center of our solar system? Without it, Earth would be adrift in search of a new center of gravity. Imagine our planet, our trusty satellite, the Moon, and all the other planets slowly floating away into space. Luckily, our trusty sun is hanging in there, keeping us warm and shining for many more cosmic adventures to come. So, we're safe for a few billion years. But it's always fun to imagine impossible scenarios. So stay tuned for more what ifs.